So we have a pretty good mix here today. So this is going to be pretty interesting. So give y'all some background about myself. Currently, I am a security engineer. So Jeffrey, I'm still caught in the matrix here doing the Sisyphean task of trying to clean things up all the time. And I work for a pretty big media company. So technically today I'm not representing my company, but if you go on my LinkedIn, you'll see exactly who I work for. So I've been working for there for the past couple of years. I'm actually a recovering government contractor. That's how I started. I'll give you more background. Began undergrad, I wanted to do computer, so I did computer science. I'm a little older, so back in my day, it was Java, and I was like, I do not want to do this. So I actually did not start out as a developer. I started out more as, I guess, today it'd be probably help desk, network admin stuff. It's kind of where I started my career. And then eventually I fell into more network engineering things, which today would probably be called DevOps. And it was the cloud back then. But when I say the cloud, it literally was VMware. So that's kind of how virtualization started. So that's where I started. And then I started getting security, doing some QA work in the beginning. So testing security tools. And then after that, I actually did some time on Red Team, which is basically hacking. And that's kind of where I started picking up that's where I picked up my programming again, because I am not very good at doing things repetitively. And so that's when I started automating things. And for me, it was Python was the big one, because the government contractor I worked for, the government office I worked for, bought an automatic testing framework written in Python, and it had no documentation. So I literally had to read code to figure out how to use the thing. And so that's kind of what started my journey on Python. So that's probably my strongest language. Originally, when I was in school, it was C++, Java, but I've not touched that in years. So if you showed it to me, I would not know what to do with it. So mostly Java, but now I'm starting to lean a little bit towards Go, because being a security engineer, I write some security tools, and I need executables or binaries that can run anywhere. And Python is not really good at compiling them that way. And also sometimes I do need speed to handle big amounts of data, because dirty little secret, if you ever want to go to security is really just looking at a lot of data and figuring out things out of it and pulling data out of it. That's what security generally is, usually log files. And it's trying to find a needle in the haystack. So that's what I do most of the day to day. But as far as containers, I kind of backed my way into it, kind of like my whole career. There's no real set path. You just kind of take turns. And the job I've had here is first to be kind of a security journalist, help to automate a lot of things. And then over time, that kind of morphed into me being on our cloud security team. So I've been doing a lot of things in AWS. When I get to my presentation, you'll see that I might focus on AWS a little bit, as well as I focus on Docker. And then for the past year and some change, I've really been doing a lot of things with containers and Kubernetes. So this is not going to be Kubernetes talk, but I will mention it towards the end. But containers, Kubernetes kind of go hand in hand. And if you're wondering what that is, that's my dog right there just roaming in the background. So there's nothing just weird about background. So that's my quick intro spiel about my career. It's been a pretty fun career. First, I have to also shout out my homie Taylor here, one of the founders of Black Code Collective, which kind of what got me here today. Is like, you join a group and you never know where it's going to take you. And it's because of that I ended up here today. And that's also one of the groups that I do a lot of talks with, and we do a lot of work there. So if you check out blackcodecollective.org. And actually, Taylor today is hosting a Women in Technology panel later on this evening. So if you check out either our meetup or our website, you'll see the information there. So today we're going to talk about a container's journey. How do you go from nothing to a container running? And just to give you background, where I started with containers or what kind of got me started on containers was about 4 or 5 years ago. Once again, being a security person, I just need to know what the developer's going to do so I can figure out how to fix it before they break it. And so that started me I went to OSCon or OSCon. And this year it was in Austin, the year I went. And I swear about half of the talks were about Docker and containers and Kubernetes. And so I said, you know what, I probably need to start learning more about this. And that's kind of where I started. And this got me interested. And I've been kind of playing with them ever since. So we can kind of just start from there. And also I try to be witty and make like a fun thing here, a story, but I discovered how hard it is to write fun, witty things. So shout out to all the TV writers out there. This is kind of hard. So, and also all these pictures, I believe the presentation is going to go up later. All these pictures come from Unsplash. So please make sure you check the links and give the artist love. Always got to show love to artists because it is hard. So let's pretend that you're a new employee that comes along to a new dev shop. Let's say it's a small startup and they kind of wrote like a proof of concept code. They said, hey, this is what we're doing. And you say, hey, this is pretty cool. And then next thing you know, they say, hey, okay, now that you onboard it, here's our code base. And you look at the code base and you just realize there's one big monolithic application that just kind of makes no sense. So in that, you kind of just sit to yourself, looking off to the distance. You start playing, Marvin's Room by Drake. You start asking many questions like, how can this code scale? Are you sure it can scale? How long do your builds take? Do you have tests built in? How can you do all this? Like, it makes no sense with this huge code base. What's going on? And so you say to yourself, you know what? I know what I'm going to do. I'm going to containerize this thing. And then you have to explain to the whole company, well, what the hell does it mean to containerize it? Because everyone says things, but no one explains what it is. So you say, you know what? All right, I'm going to explain exactly what containers are. And this is what you're going to do. So this is the point where I go back to the traditional presentation of bullet points because I couldn't find any good pictures and stuff like that. So sorry, y'all. First thing is, what is a container? You can Google all the definitions you want, but I'm going to give you my definition. So that's why I call it the brand definition. It's a virtualization technology that allows packaging of software and its dependencies to allow the software to be ran anywhere. And when I say anywhere, I mean on cloud, on premise, on your local machine, on someone else's smaller local machine, such as like a Raspberry Pi, those type of things, which you probably couldn't do. But also, I'm going to talk with my hands a lot because it's easy for me to visualize containers by, literally being a container and squares and stuff inside the square. So if you're going to see me do this a lot, I'm talking about container. That's what I mean when I say that. The first thing I want to get across is, especially folks who have like experience with virtual machines, containers are not virtual machines. The key difference is containers are supposed to be really lightweight and literally only supposed to have whatever in them it needs to run. So if you've ever looked at, I heard we have like some Windows users here. We also have some new folks at technology. And so I will say this is a good topic to also kind of learn about how computers work. So, code boot camps in general are really good about telling you programming languages, but sometimes it doesn't tell you what's going on underneath. And so that's why I was kind of thinking for some of my time in doing IT type things, because you kind of learn how computers work underneath of the code, and how that helps you as a developer is it teaches you how you can write your code to use like the better part of computers. So especially when it comes to scaling, especially in cloud space. So you have what are called instance classes in AWS. You have some that are high in memory, and you also have some that are high in like CPU. And depending on what kind of code you're writing, you can figure out what it is. So for my Python developers, you tend to want higher memory because that's typically where your code runs. Versus when you're running Go and it's using the CPU to do things, trying to get them done faster, you probably want to be on those. So learning the backend kind of helps a lot with that stuff as well, or learning how computers work that way. So I would suggest, just taking a quick, just saying, what's a CPU, GPU, memory, all that type of stuff. It's always good to learn that stuff as well, just so you can have an idea how your code works. Of course, reach out to me if you have any questions. But a virtual machine is essentially taking a physical computer and virtualizing. So you can have many computers running on one computer, but typically that takes a lot of horsepower to run that. You need a lot of CPU, you need a lot of memory to run that type of thing. A container is basically saying, I'm going to strip out everything out of there that's not necessary. So if you've ever had a Linux machine and you've been on the command line, if you go, I guess, if you type the words ls/etc/bin, or excuse me, etc is probably a good place it is in the bin, you'll see there's a lot of programs in there, and there's a lot of what are called executable files in there. And in a virtual machine, you're going to have a copy of all those in there. So it's basically taking everything it takes to run a machine and putting it in there. What a container does is it strips out a lot of that, and only, like I said, it only uses the bare necessities. We'll get into that a little bit later. The next point is something that's more of a, when you're talking to people online, some people's going to always do the well actually. So this is to kind of protect you from the well actually police here. A lot of people say Docker and they confuse it with containers. Or no, I have to say this right, and I have to read this myself. So when you hear Docker, they are talking about containers, but not all containers are Docker. Being that there's a thing called the Open Container Initiative. That's the next point. And the Open Container Initiative, they essentially put out these two specifications. So they have what's called the container image specification and container runtime specification. And in the image specification, most people are just familiar with Docker. And that is the majority of it. In this talk, I will focus on Docker, but there's other things out there, and I'll get into it later. So there's different ways you can make containers. So Docker is one way. The other way is a program called Buildah, Buildah, which makes OCI compliant containers because it adheres to the specification. So there are other container technologies out there. And when I say container, I'm talking about the base level. It will get higher when we get to the runtime. That's a different part as well. But when it comes to containers, there's really just specification. And technically speaking, if you wanted to, you can make I can make the branded I can make the branded containers if I really wanted to, if I want to go out there and write my own stuff and make sure I adhere to specification. Um, Before I put these up, I will put the links in there. There are links in here, but it's not showing up. So when this is posted, there are links to the actual specifications if you want to take a read through those, which also is another tip I would say for the new technologists. If you ever need some aid to go to sleep, you could read these specifications, any specifications or RFCs. However, it is good to know how things work on the underneath them. So if you get some time, look at them. Like I said, I'm not very, it's hard for me to focus sometimes, so I have to read them in chunks, but I would always say check that out. And also the Open Container Initiative has a website, so make sure you check that as well. So let's start from the very, very beginning of how you even make a container. So the first thing you want to do is you want to create what's called a Docker file. And a Docker file is a simple text file. That's all it is. You can kind of think of it as like a setup.script. So for my folks here who does some DevOps, I'm sure you've called it whatever you called it, but you've had some kind of shell script that you've written stuff out so that when the computer turns on, it execute those functions, those instructions, and it does its thing and sets up your computer the way you like it. So that's essentially what Dockerfile does. It says, hey, I'm going to make a container and I need these specific things in there. And you can run commands that way. You can do all types of things. If some AWS users out there, you could think of it as I think it's called user data. You can think of it as user data. So essentially it's a shell script, or it's like a shell script. And you can kind of set up the container itself. Actually, excuse me, let me use the correct terminology so we don't get well actually later. This helps set up a Docker image. It's not the Docker container until it's actually running. And we'll get into that later, but it's a Docker image. So you have a Docker file to a Docker image. And then once you actually run that Docker image, that's when it becomes a container. So I might go through those different things, but I'm gonna try to use the right terminology here. One thing I'll say about Docker files, they all begin with the from statement. And that essentially says, the cool thing about containers is images and containers, you can build upon other people's work. So when you use the from, what you could do is I could say, hey, I want the Ubuntu one. So I could say, pull in the Ubuntu base, and then I can add things on top of that. Or if Taylor writes something, I say, oh, I like Taylor's container, but I need to add some more things to that. I can just pull in Taylor's container, which is one line, and can build on top of that. Or they even have one called Scratch, which we'll show in a second, which is the base one. And if you go look at a lot of the OS ones, that's how they start. They start from scratch, which means they start from nothing. Here's for my developers. So if you work for a company that doesn't have standards, this gives you leverage to figure out what you want to do. So when I say standards, I mean, if they say, thou shalt use Ubuntu, thou shalt use CentOS, the cool thing about containers is you can kind of play around with the different operating systems and see what will work best for you. I tend to be an Ubuntu user. I like it, but my company, Rail and CentOS is probably the bigger one, but we have no standards. So when I make my containers, I tend to use Ubuntu for my base. And there's nothing stopping me. So it's kind of up to me when I write code of how I want to do it. So the choice is up to you, which also can make your ops people shudder a little bit. But in a container world, it might not matter to them too much because they say, I just set the playground for your container. What you put inside of my playground is on you. So this is one little cool thing about Dockerfile. You kind of make this decision early. And the other cool thing is with containers is if this is not right, if you don't like this, it's pretty easy to change it because you literally just go back to this Docker file and say, oh, I don't like Ubuntu. Let me try CentOS. You go back and just boom, just change literally one line and say, okay, instead of Ubuntu, I want CentOS. And now you have a new image and then you can create a new container from that. And then also even cooler than that is at that point, now you can have two images so you can actually play around with both of them and kind of run your tests through both and see which one actually does work better. So it's pretty easy. Typically, you'll see people's Docker files in source control, Git or Subversion or whatever you're using in your company. If you go and look on GitHub and literally probably just search for Docker file, literally wrote like it is at the top, just Docker file, no extension on it, you'll probably see plenty of Docker files. I know for me personally, I've been working on a project that is container based at work, and I've had to pull things out. So the open source project I'm using, I need to pull parts out of their container and their Docker file. So I literally just looked for their Docker file in GitHub, which is out there because it's open source, and I pulled the pieces out of it that I need to. And it also helps me reverse engineer some things. So, the stuff is out there. It's pretty open. And most IDEs probably support it. Visual Studio Code has plugins to help you make sure you put the right things in there. So as soon as you put the from, Visual Studio Code does the IntelliSense popping up to make sure you put a lot of things in there. And then also Docker itself. So Ironically enough, I say Docker is not the main thing, but this is usually the way most people do it is by using Docker files. Even the other technologies kind of use Docker files as well. Docker has pretty good documentation on their website. That's another thing about this talk. This is me reading, this is me interpreting Docker's documentation, so you don't have to, but we could talk about more of that later. So I will recommend using an IDE, but if you really wanted to, you could just use Vim or Emacs or whatever your editor of choice is. So I just wanted to show a quick Docker files out there on internet, and hopefully everyone can see this. But this right here is the. Can you see my my cursor here spinning?
Sure can.
Okay, cool. So this is an example of what I was saying from scratch. So this is kind of how Ubuntu literally builds one of their Docker images. So they take from scratch and then they add all types of things. So like this add command is probably on whatever build machine or whatever, like a local host or whatever. So it's adding this to the container. We'll kind of get into this later, what some of these commands do. But and then there's run is kind of like actually running command inside that new image. And this is how, so you can think of it spinning up as a temporary container and it's doing all these instructions. So it's kind of going from top to bottom, doing all this stuff in order. So this is actually how they build the Docker, the Ubuntu Docker image. The next one is kind of showing you an application that a lot of folks use. So Nginx is a web server. And so you can see from on this instance, from this instance, Nginx is using the Alpine container. And Alpine is pretty interesting because it's kind of an operating system that was purposely written for containers. It's very, very small. I think Alpine, the standard is like 5 megs. That's how big the operating system is. And from there, you can kind of add things in there. And Alpine does have a little, their packaging is a little different than normal things. Typically in Ubuntu and CentOS, you use apt and yum to update things. And Alpine use what's called APK. And they have a lot of it documented. And quite honestly, I have to Google it a lot of times when I use it. But there are limitations when you use something this small. They make sacrifices, like they don't have compilers in there, and certain things don't run right inside Alpine. So, but what they're doing here is they're just showing you, how to make a how the Nginx folks make the small Nginx container. So that way, if you ever want to kind of play around with the web server or the web proxy, this is how they build it, and then you can go out there and pull down the image itself. So that's what this one is. And then right here is an optimization thing. This is called a multi-stage build. And so what I'm doing here is to go through this. So this is kind of one of these optimizations we can talk about, especially for our DevOps folks, and even for developers, if you want to make your container as small as possible, which you should. So to go back to Golang, Golang is a compiled language. And so you write your code and you need to compile it out to executable. There's no reason for you to have that compiler. There's no reason for you to have your source code into your actual production container. So what you could do inside of multi-stage builds is you can kind of use 2 different containers during the build cycle to get your thing. So what I'm doing here first is I'm saying, hey, get the Golang container, which has the compilers and all that stuff in there. I'm copying over my actual code here, the test.go, into this directory. And then I'm building it. So I'm compiling the Go. And so what this is doing is actually just compiling it, and it outputs a file with the same name with no extension. So that's what you're kind of not seeing there. And then what I can actually say is for my production container, I will actually use the Alpine, that really, really small one. And then I'm going to copy from here that one little file over. And so now it's in there. So now my production container doesn't have all those Go dependencies because I don't need it. I just need the actual executable. All other stuff inside here, I really don't need. So this is how you kind of keep things smaller. This is really good, especially for compiling languages when we build things. This is one way a lot of people do things. And then finally, making it executable. So we talk about the Docker file, and I say, after you write your Docker file, you have to build your image. So this is what a Docker build command does. So it takes it from the Docker file to OCI compliant image, if you're using things such as Builder or Docker itself. And the way this works is it creates what are called layers. So these are how containers work. So if you ever notice, whenever someone's talking about containers, they always have that picture of ships with actual containers on it. They do that for a couple of reasons. One, because sometimes you'll have multiple containers doing multiple things, but also because they're really built in layers. And one of the cool things is that every time you run one of these commands here, these are specific commands. From is the initial one, like it says, brings in whatever images out there. Copy is what you could copy something from your local file system to the image file system. Run literally runs command inside of it, and also command does the same thing. So run and command actually do kind of the same thing, except command you want to use that one towards the end of a Docker file. We kind of get to that later. But each one of those things builds what's called a layer. And so one that probably is used the most will probably copy and run. And the cool thing about this is it creates a layer. So let's say you work for a company, and let's say you have a base like, forgive my JavaScript folks, forgive me for just talking wrong for this, but if you use a minified JS file that you must put into everything, I think that's the right words, I don't know. So if everyone puts that copy this minified JS file, it's going to create one layer. And where that comes in at the later on is when I talk about Docker registries is you can, it creates a SHA value for that. And so that way, if I make one and you make one, they'll have the same SHA, and that way we can actually reuse layers at that point. And that kind of comes into some of the ops stuff of when it comes to storage things. Since the layer is the same, Docker is smart enough to know, or when we push it to our registry, which I'll get to in a second, it'll say, oh, I've already seen this layer, so I don't need to push it. So that kind of helps with a lot of things. And if you're local, you'll rebuild a container. So if I do one container with that layer and then I make a totally different container that's doing something else, but it has that same file, my computer's smart enough when it's building the thing, it'll say, oh, I've already seen this layer. There's no need for me to recreate it. I'll just pull this other one over. So layers are kind of how all it's done. And we'll get to it in 1 second. I'll show you an example of how all that plays together. One other thing I want to bring up that is very confusing and dangerous are tags. They're good, but they can also be dangerous. Mostly tags are how you can think of it as versioning your images. So most folks usually do something like Brandon's container : 0.1, 0.2, or you could do Brandon's container : latest. And I really want to talk about that latest tag because a lot of people will tend to think that latest means it was the latest one built, but actually what it means is kind of default. And this is where ops and your devs probably need to talk a lot about how they want to do that. Because if everyone agrees that latest literally does mean the latest build of something, then you're fine. But not everyone means that. Some people can just say, oh no, I actually put a version in there. I know one convention we have at our job is for Linux. We say, Linux 7 dash latest, and that will actually get in the latest version of the Linux build versus if I did Linux latest, it might not get me the latest version that's actually built. It could be something that's kind of old that they might have done some updates to. So if you're going to work with open source things, or if you're going to work within your company, I would say you need to have that conversation between the devs and ops of what latest means and what it means to you. If you go and Google this, you're going to see there's a lot of arguments for this either way. I'm not telling you which was right. I think latest should be late. Okay, I'm gonna say what I say, what I feel. Latest should be latest, but it doesn't always work that way. So after you've built your image locally, the next thing you want to do is you need to share that image. So be it from your computer to the dev, to the actual ops folks, or from, if you want to just share it with the world, like you do any open source thing. What you want to use is a registry. So registries are pretty interesting. So this is where you actually push all those layers up to, and it describes how your image looks. So registries can actually be locally hosted if you want to. If you go to Docker, they'll tell you how you can host a local one. And ironically enough, registries themselves are usually containers. So it just says run this container, and now you can have a local registry if you want to. I wouldn't recommend that, well, if you want to play around with it, sure, you can do that at home, but I wouldn't recommend doing it like on your local machine because technically your machine's kind of registry itself anyways. Hub.docker.com is kind of the big one that a lot of people use because it was kind of the first one. And what that does is it gives you, so within a registry, you have what are called repositories. So that's kind of a namespace dedicated to you. And if you look at it, they're usually like a org / whatever. So it's kind of very similar to Git. So there's probably something like Brandon Co / Brandon, and that will be for me. But if you have Brandon Co / Frederick, that will be Frederick space, and that's all for him. So that's how it is. But if you go look at Nginx, you'll probably see something like Nginx / proxy, Nginx / whatever. The thing about, and so you can have public ones that are open to everyone in the world, and they can pull your containers from hub.docker.com. And that's usually the default. When you use Docker, it's actually checking hub.docker.com to see if the container's there. So if you build something at work, and let's say you push it to your work internal registry, and then you run a Docker pull, and let's say you kind of mistype something, your Docker is probably actually going to try to go to the actual internet one first before it goes to your internal one. So that's just something to kind of keep in mind. Like I said, you have public ones where anyone can pull the containers down, but you also have private repos. So it's very similar to kind of Git code. So you can have things out there in the public, you can have things kind of hidden away. One thing that's happened with hub.docker.com is Docker realized how much money it costs to host all these things because people push all types of things in there. And then also it's an insane amount of traffic that happens. If you're pulling down a really big container, I guess for my JavaScript folks, I can't remember what it's called, but it's like doing an npm install or whatever, and you know how long that could take. This is back when I tried to do front end, and shout out to people who do front end because I can't do it. I learned back then that you can't do an npm install across a Wi-Fi at a cafe because it'll take forever. Docker can be very similar. You don't want to do a Docker pull on a big image across a Wi-Fi because they can be huge, but the standard should be to make a smaller one. But also Docker realizes it's a lot of money to have that traffic going in and out. So they made an announcement a couple weeks ago. That's what that link is. They're going to start rate limiting folks. And where this really comes into play is folks, especially my DevOps people, a lot of build systems actually use containers. And so imagine if you're making a build and every time you make a build, your build system calls out to hub.docker.com to pull down a certain container to start running its build inside of it. You can imagine if you're running a whole bunch of jobs a day, you're going to make a lot of those calls. So that's why they're saying, nope, we're going to rate limit. And at my job, it did break some folks' things because we use containers to build our stuff in. And so what we do now is we mirror the images. So what's on hub.docker.com, you go to the team and say, hey, I need this mirrored inside. And so now we're pulling from our internal registry. And then that team who runs that internal registry, they make sure that their stuff is in line with what is out there on the internet. So that is like one way to get around that, is to run your internal registry and kind of mirror what's out there. I'm not totally sure what magic they use, but I'm pretty sure it's some kind of scripting. To kind of combat that, or not really combat that, but give people an alternative, AWS came out and said, hey, so AWS has their own container running things. One thing they have is something called ECR, which is the Elastic Container Registry, which typically is scoped to just your AWS account. But now that Docker kind of is rate limiting things, they said, hey, we're going to open this to the internet. So if you want to, projects can put their containers up there so they're open to anybody. So this is actually fairly recent that ECR has been opened up to the public, meaning that anyone can pull from images there, but that is something pretty new. I've played around with it once because for my AWS folks here, my DevOps folks, I do a lot of Lambda, but Lambda is kind of hard to test locally, but containers are pretty easy to test locally. And they just announced that, or a couple of weeks ago, they announced that you can use containers inside of Lambda, but you can use their container. So what I've done is I pull down the Python container from AWS and use that for some of my projects. And then I push that to my ECR, and then I use Lambda and just say, hey, use this container for the Lambda, which is pretty cool. For those who haven't used AWS, Lambda is essentially, it's kind of containers before containers, but essentially is AWS saying, I'm going to run this code for you. You don't have to worry about servers or anything like that. Just tell me how much memory I need. And it does it. But the thing is, it's time boxed. You go and do it within 13 minutes. And they do have some limits, but they're pretty big about how much data you can do in that. But back to the registry, but these registries are all API driven. There's actual documentation about that. So this is what this link will send you to. And just give you an idea of what would happen if you query a registry and say, hey, tell me about this image. So this is telling you, the schema version, and it's telling you a little bit about the configuration of it. The important part is the layers, what I was talking about earlier about it taking a SHA value. So SHAs essentially are SHA digest. And essentially what a SHA does is it's getting you a hash of something. So it's just basically saying, okay, all these bits are a certain way. I'm going to do some mathematical operations on it, and it's going to give me a unique number. And I'm going to say, okay, this is the same thing. And so what I was saying earlier about if we have that same minify.js file, the image will keep that in there. But like I said, for folks who are running our DevOps or running that registry, they don't have to worry about storing each one of these because as you can see, they all have different sizes. And if you have a container, or if you have a big company, a lot of people are using the same things over and over again, why would you save the same file over and over again if it's used? What the SHA is saying is, oh, this already exists, so I don't have to pull it. And if you ever run a Docker pull, especially 2 times, you'll see sometimes how those layers already exist, and you'll say, already exists and doesn't push or pull it. So it's pretty interesting to see. And also, as you can see right here, your layers that I talked about when you add things in are really just gzip files. So technically speaking, when you create a image on your machine, there is a path, which I do not remember off the top of my head right now, you can kind of dive down into and actually see the gzip files. And if you want to break it open, it's probably just binary. I wouldn't recommend it, but you could. And one last thing here is interesting that I think a lot of people use are annotations. This is a security person and me coming out here. This is very helpful helpful because this is tags your images, and it can, a company can put standards out there to say, okay, I want to know that this team did this, so we want to make sure they put an annotation in there so that way we do it. So this can be part of your build process. Currently in my company, we put it as part of our CI/CD process. So the developers themselves don't even have to do anything with it. It just kind of goes in there and it's tagged. And if you run a command on it, you can pull those information out. But for most people, they don't care about it. But it's something pretty interesting to look at. We use this a lot. Runtime. So runtime is basically what happens. My definition of what container runtime is are the processes that actually handle running a container. So this is going from image to container. There are OCI compliant runtimes. Here are the main ones: runc, cryo, containerd, and LXC. LXC is kind of like how container started. Runc is actually what's happening underneath Docker. So Docker is really an abstraction on top of runc. So it's an API making calls back and forth to make all that happen. Cryo and containerd are typically used in Kubernetes. So I'm not gonna get too much into those. And actually containerd, it's being used a lot more because Kubernetes announced a couple of weeks ago that Docker will no longer be their default runtime. So everyone's switching to containerd. So that's what I've been doing a lot at my job, is making sure my tooling still works on containerd. And below is the actual command that you run to actually get a container running. So, and I'm going to try to, I'm going to do this next. I'm trying to run through here so we get some time to talk at the end. But one thing I will say about containers, and I haven't put this out about minifying it, the big thing about containers are containers supposed to do one thing and one thing only. So, if you have one for a database, it should only be doing database, that's it. If you have one web hosting, that's all it should do. And it should do that with one process. So, and the reason for that is because once that one process quits, so your main process, once that quits, your container goes away. And so that's another thing about containers. They're immutable, which means once I make the image, it shouldn't change much. One issue that I know I've seen at my job are people put things in there. So when the container spins up, it runs other scripts to do more install. And it shouldn't be that way because once my container is created, it shouldn't change. So that way we know it's in there. So that's one thing to keep in mind. You want to make sure your containers are immutable. And you want to make sure that when they start to do their one process. So, if it's something like I said, a database server, which I always think it's why people run databases as containers, but it's possible. It's going to kick off your MySQL command, and it's going to keep running until something interrupts that or kills that. So just make sure that you have that, and it's typically handled in what's called the entrypoint.sh file. And so if you look at a lot of Docker files, you'll see they'll have something called like docker-entrypoint.sh or entrypoint.sh. And usually, if you look at the Docker file, that's the last line. And what it's saying is, go to the shell script over here, and that shell script is doing some things. And the last thing it does is it runs some kind of process that's either going to, do its job and then exit the container, or it's going to kind of stay open. So like Nginx would, start the Nginx process, and that's the main one. Or if you're just running like I think we had someone here talk about AI. So what it will do is probably start the learning process. So like a TensorFlow container will probably kick off the TensorFlow process to do whatever it's going to do. And then when it's done, the container quits out. It'll probably put the results somewhere and then quit the whole thing out. Ops benefits, real quick. You can do uniform operating systems. So like I said earlier, if your developer wants to do CentOS, but you want to use Rail, it doesn't matter, because for the ops folks, what you're saying is, I just need to make sure your platform is the same. So they could say, hey, we can make sure all Linux machines are blah, blah, blah. But there's even now container focused operating systems. So BottleRocket is the one by AWS. There used to be one called RKT Rocket that got bought by, and CoreOS. Both of those operating systems were actually container focused, but they've kind of gone bye-bye. They got bought out, but BottleRocket is kind of one of the newer ones. So you could just say, okay, as an ops person, I'm just going to make a whole bunch of BottleRocket servers, and I can't get too much into it because I haven't played around with it yet. And people can just run the containers in that way. You can also get easier blue-green deployment. So it's easy to say, all right, we'll put a new tag out here. Oh, if it doesn't work, then roll it back because we had the old tag. So it makes it very easy to spin things out. This is kind of where Kubernetes and all that stuff comes into play to mix that. And also resource protectability, because you have a general idea of how much a container uses. So you can say, okay, I know I have 20 gigs over here, and I know each container takes 2 gigs, so I know I can put 10 over there. You can kind of figure things out. As long as things don't spike, it's pretty easy to figure out. Once again, also the cost benefits. If you have better planning, you know how to take advantage of different things. I also believe that containers, this is once again a brand opinion, they're on a critical path to serverless infrastructure, especially if you're using cloud providers. They have a lot of things out there. So AWS has ECS Fargate, which essentially means I give AWS a container, they run it. I don't care about the server that's running underneath it. They handle all that for me. And then, like I said, some advanced topics. So Kubernetes, Mesos, Docker Compose, essentially what these are orchestrators. So you kind of write a file. So for Kubernetes, it's YAML mostly. Actually, most of them are YAML or JSON. And you're saying, hey, I need this container, this container, this container. I need that many of them. It can use this much memory. It can use this much blah, blah, blah. And you can figure all that out from there. So that's kind of what they do. So they make sure you have that many running. And that's pretty much what all these do. Like I said, Fargate is AWS's version of doing this with no servers at all. ECS is doing it with servers. EKS, GKE, Google Kubernetes Energy or Engine, and Azure Container Service, or AKS, Azure Kubernetes, is basically everyone moving Kubernetes to the cloud for you to use. I've only had experience with EKS. At some point, I want to do some personal projects on GKE to kind of see how it is. They just came out with a new thing called Autopilot, where they kind of do a lot of defaults for you. Kubernetes will be a whole nother talk. That will take over an hour to go through it. It's very confusing, but Kubernetes is a pretty interesting way of running containers there. So, and then of course, the last thing I always want to pull out, just to let everyone know, I've been working on containers for a year and a half, been in tech for like 10 years. I still Google and Stack Overflow a lot of things and a lot of basic things. Like for a Python person who's been doing Python for 5-6 years, I still always have to Google how to do dates and how to import CSVs because I forget the thing every time. So here's some things I always have to do. How to mount volumes. So this is just one quick thing of saying, because when you look at it, sometimes it's hard to tell which is which. So this is saying when I'm running a container and I want to share data from my computer to the container, this is saying, oh, this is the data I want to share on my local host, and this is where it should be in the container. So for like that database example, this would be where the file will be written on my machine, and this is where it'd be in the container. Just kind of a quick thing. How to log into a Alpine thing, because Alpine doesn't use Bash, so always have to look at that. Entry point versus command. Entry point if you want to override. So this is kind of more advanced thing, but you can Google that. We can talk about that later. I want to get the questions. And copy versus add. Security person, use copy. Add, what you can do with add is you can actually add, and what that's saying is put something inside my image. Copy just says literally, I have to know exactly what this is and put it in here. Whereas add can actually use get and pull from the internet to put something into a container. And the issue with that is don't trust the internet to put things on run the things. One of the things that makes me always shudder is when people say, hey, run this command straight to shell. Like I know you have to like brew, you have to install it that way. But God, that is terrible because people can put whatever they want to in there and cause whatever issues. But that is it. I want to do a quick demo. Ironically enough, we did have a Splunk person on here to show if you ever installed Splunk, you know how long it is, how much it takes to do that. Let's do this. While I'm doing this, you can ask questions. I'm just going to show how quickly I can get Splunk running on my machine. So right here, I don't have Splunk running. Let me copy this one command. So this right here, make this bigger for y'all. This right here command will literally start a Splunk container. So if you ever installed software, you know how long that takes. So we can talk about how quickly this happens. So while this is running, feel free to ask questions.
Hey, Brandon, I got a real quick question for you, man. I know like containerd is like the real popular container runtime at this point. What benefits would a developer have for even beginning to learn other runtimes than just using what's default?
To be honest with you, a developer, it wouldn't matter to the developer. It's more to your ops team. I would say ops is probably more concerned with that. It's because how they want to work things in their Kubernetes cluster. That's usually we're going to run into is Kubernetes. I would say that's more of an ops decision than a developer decision, because developer can use things inside Docker on their local machine to test it out. And then when they say, okay, my container is good to go, By the way, see, look, now I already have an actual live Splunk running.
That's because I'm here.
Yep. By the way, shout out to Splunk for putting that in there. I love it. The fact that so this is an example of hub.docker.com, and they tell you how to pull down their Splunk container, and they even give you the command to run it. And I literally use this all the time. At work, I have this aliased, and I use it all the time because we have a huge Splunk cluster, but I need to test things out before I send it there. So just let you know, if you want to run Splunk locally, it would be a lot of horsepower and a lot of time to get that thing set up. So this is pretty cool. So this is the power of containers. And to finish up my answer to Emmanuel, yeah, it's I would say it's more of an ops decision, and even then, it's more so what you want to do in your environment. So you can use containerd or cryo. I know, like I said, my company, we're moving from Docker to containerd. I wasn't part of the conversation of why they chose that, but that's what they chose.
Cool.
So, and then, so here are some of the Docker commands you'll probably learn over time. So Docker PS shows me the container that's running. So a lot of things are handled by hashes. So this is the full hash of the container when it launched itself. It's telling me the ID of it, what container it is. So you can see I'm using latest here. That is kind of what Splunk is using. And to kind of give you an example, cool thing that Docker does is if you go to tags, it'll show you the actual tags that they use. So Edge is kind of probably like their bleeding edge build and all that. And the other cool thing is I noticed yesterday is now they have this sort by thing, so you can see what is the actual newest. So when I'm using latest, I am not using the latest. I'm using something different. So that just kind of shows you how the tags run. You kind of run through here and see what's going on. But yeah, so Docker PS shows me, you know, the command that it ran to start it, how long it's been running, if it's still running, and then also what ports it's using exposed out, which is also another thing I have to Google all the time because I forget which order those go in. If you look at this right here, this P 8000, 8000, I forget which one's local host, which one's container. It confuses me every time. Any more questions? Especially for the new tech folks, man. Come on, y'all.
Do you like, I mean, I guess why would you use Docker? Is it for testing only?
So not exclusively, you could use it in production. It's being used in production. But like I said, Docker is essentially a API over Run C. So Docker is just kind of more commonplace, I would say. It's a lot easier to find resources about it, what's going on, especially if issues. Containerd, I know our team has run into issues and they had to go back to the Containerd project and make issues that way. Docker, you tend to have a little bit more, it's more user-friendly, I would say. It's more beginner-friendly, more documentation, and we have more people using it. You have more questions that you can ask more people about what's going on. So I definitely recommend Docker to begin with, but when it gets to production, so switching to like something like Containerd and Kubernetes, I'll say that's more of an ops question. As a developer, what you might need to know in that interim is how much horsepower does your thing need? So your ops team might tell you, you can only limit this to 10 megs or something like that, or so much time on the CPU. And so you might want to take that in and you could probably play around with your Docker settings, which, so Docker actually now is pretty nice. They have these dashboards now, it shows you everything going on. And one thing you can do is look at your settings and like look at your resources. So you can kind of like squeeze down your Docker and make sure it still runs, because this is how you control the resources. So Docker can use a lot of space if it wants to. These are my defaults. Fun story also, if you're using Docker, make sure you turn this off, because for whatever reason, if you have that turned on, especially on MacBooks, it will make your fan spin. So at my company, our Docker Slack channel, there's a big thread about that, and people were trying to figure it out, and it took a long time. And as soon as that thing was, it's pretty interesting. No matter what container you ran, it's ate up all the CPU and made your fan spin up. It was kind of crazy. I think someone put an issue in the Docker for that one. And also something Docker does now is they allow Kubernetes. I haven't played around with this too much, but if you want to play around with Kubernetes also, here. But I would say before you do Kubernetes, make sure you have a solid understanding of containers themselves, because Kubernetes can get very confusing very quickly.
Do they use kind for that?
For what?
For the Kubernetes support?
I have no idea what they use. I haven't played around with it too much, so I have no idea what it's used. I'm pretty sure. I have no idea. It might
It's
be
cool. Yeah, I didn't even know
K3s.
that was a feature. I'll take a look at that too.
Yeah.
Yeah, it's not kind. They have their own flavor, Kubernetes for desktop, something like that.
Yep. And so another thing that's changed with Docker over time, and maybe I just don't see it anymore, is Docker used to actually, ironically enough, when I say containers are not virtual machines, Docker used to actually put a virtual machine on your actual laptop and run the containers inside that. I don't think they do that anymore. I could be totally wrong, but maybe I just missed it. But it's because I have VirtualBox installed on my machine, so I never really noticed. But yeah, and then also for Windows folks, cool thing about now Docker actually is supported on Windows. I don't think you need to have the WSL up and running. I'm not totally sure. I don't have a Windows machine. I haven't played around with it too much, but I'm not sure if you need to have the Linux running on Windows in order for Docker to run. But I know Docker is putting effort in to at least get containers to be able to run on Windows machines. So that's pretty cool. If you're a Windows developer, you can still kind of play around with Linux stuff, either by using WSL or you can actually use Docker as well. I
Very
got a few
cool.
minutes
So
to hang around too. Yeah.
awesome. Thanks, Brandon. I know we're getting close to 10, but if anybody wants to maybe ask one more question, we could squeeze in one more.
I have one more, Brandon.
Sure.
So this is something I heard about, like given the complexity, added complexity of working with containers locally, is it always worth it to put in the extra time to use them?
I would say yes, because it makes your process to production a little bit faster. And honestly, well, I'm gonna say this is bad. From my perspective, it's pretty easy to put things inside containers, but that's mostly because I use Python. So literally, I'm just copying a file over, or I'm compiling a file and go. But if you have bigger systems, I see how it could be more complex. But that's where I'll also say work with your ops team, so they can set you up at least so that way, if everyone's on the same process, so if they understand how you build, then they can also understand. Okay, when I pull this image, I know it's already there. So I would say it might be slightly more complex in the beginning, but after that, it probably gets easier. So there's a little bit of cost to pay. It comes with all things. Like going to the cloud, people say cloud's confusing. It's like it can be at first, but once you get over your initial hump, it starts to make a lot more sense and a little bit easier. And then also that's where automation becomes your friend. Do a lot of that. For instance, a lot of my work stuff, I actually use shell scripts to do a lot of my build for me. So for AWS, to push in there, you got to do a few different commands. I scripted that out. So literally I just do /build and it does my Docker build, it tags things and it pushes it to where I need to go. With me just running one command.
And to make sure I'm under, like follow into, you're saying like leaning into like everybody being on the same page as far as processes and stuff like that as you grow, to kind of keep things more simple.
Yep. Document, and document again. For my intro technologists, if you want to go far, learn to document, learn to understand documentation, and help other people with documentation. Document all the things. It's my biggest advice I always say to new folks in technology.
And working on making it concise, because some people get like so verbose, but like being concise with your documentation too, but like still covering the main points is.
Yep. Even to put more to that, pictures also help too, especially when you're talking about systems. I am a big user of Lucid Charts. So Lucid Charts with AWS, I put a lot of things in there saying, okay, let's go from here to here to here to here. So that ECS icon, trust me, I use that a lot. So.
I have one quick question. We have time?
Yeah, sure.
Just the point of using containers at all, really, you want to see how your application is going to act on that specific operating system with those under those conditions, like the conditions that you specify with those services, correct? You're trying to make sure that it can run anywhere, and you want to see how it's going to act on like this specific OS under these specific conditions, correct?
That's part of it. I would say yes. It's more so, I guess, encapsulation. So it kind of helps promote that whole thing, like tightly cohesive, loosely coupled. So containers help with tight cohesion because you know everything that you need inside your container to run. And then you say, oh, okay, this container runs, and then I can figure out what other things could that container play with. And that's where like Kubernetes and all that stuff comes in. Because you can say, oh, I can use this container, that container. So that's where it helps with the coupling. But like kind of the point of containers is, I guess, is a good way of boxing things or abstracting things. So that was pretty easy what's going on. And since you know it's in that box and you keep it very simple, you know exactly what that box does. So I think it simplifies a lot of your stuff, especially in the world of, that's one thing I forgot to put in here. There's a YouTube video that's kind of a joke about microservices. And this is where containers really shine. So essentially, every microservice, every little service that does a little thing, you can think of that as a separate container. And then you can think of ways how they can communicate with each other. So containers really help with like breaking apart big chunks of code. If you had a monolithic code base though, I would be wary about putting it in a container because you might have a lot of stuff in there that you don't need for whatever part you're running. So containers really help if you're going towards the whole microservices, keeping things separated. As a security professional, I like keeping things separated mostly because that means I know what to look at and know if something's off. That's kind of one indication there that, if all of a sudden something that should be spitting out JSON is spitting out XML for whatever reason, something might be going on there. And that could also be a flag for your ops folks to take a look at it, your devs to look at it. So I like to separate it out, and also use some security boundaries in there when you do that.
That's clear. Thank you.
Mm-hmm. Yeah, being a security person, I always bring everything back to security at some point. So I apologize for that. Use password managers. This is the last thing I'll say.